You have seen what? I haven't understand the first.
Stripes or lines with shrubs and trees. There was one picture with...
In which was it?
Doesn't matter. I mean, some green patches, green spaces with trees. Is it common?
Yes, it's in discussion. It's not common now, but they discuss it and they want to do it further now due to the common improvement of the soils. Yeah, but it's not common now. Not. We can't hear you.
Once again, congratulations on your good work. I wanted to check if you may have considered having maybe a plot that you do not put these practices like mechanical tillage, because we've observed that if you don't disturb the soil, the microorganism habitat that tends to behave differently compared to when you plow or till the soil. So I wanted to ask with you, to check with you if you have considered maybe applying these soil amendments into those plots that you do not disturb and then observe over time to serve maybe as a control.
I will try to translate, to simplify. If you consider to have a plot with no tillage system, I mean without mechanical activities on the soil for the soil preparation, because it's known that generally in this type of soil that are not work mechanically, the microbiology it's increasing and generally the soil life is higher.
Mm-hmm. We always the time we have tillage, so they tillage the soil. So we have not an area with no tillage. So therefore, there's no difference between it. And we recommended it, but most of the companies say, okay, we want to do it like we have done it before. So we have to look. It's not like the crops like wheat and so on in vegetable farms. It's a very high pressure to produce very good products, and therefore they are very shy to use new methods, and therefore, yeah. It's, but if you are, I haven't shown results from the microorganism, but in most of the fields the results were very good. So yeah, we also want to look for nematodes, but then we thought, okay, it's so many results, so many methods, it takes too long time for the nematodes. Maybe we thought about, we have a look to the recommendations after the soil sampling, but we have to look for the time. So, yeah.
I wanted also to ask something similar. I mean, if you did on those plots also deep ripening, I mean ripening with deep reapers at 60 or 80 centimeters, generally this method is used instead of ploughing to enhance the soil aeration and to reduce the compactation of the soil. So not this type of works.
We have information about all the methods, the tillage and so on, but they don't give information about the depth. That was the problem, and therefore they said normally only 30 to 35 centimeter depth. That's what's normal for the soils. Yeah.
Thank you. Thank you. Now we are moving. Now we are moving on to the next speaker, Mr. Nicholas Nyambo from University of Mpumalanga, South Africa. He will speak about research on evaluation of the phytochemical composition of two nematicidal plants, Merua angolensis and Tabernea montana elegans, against nematodes.
Ladies and gentlemen, be greeted. As I have been introduced, I'm Nicholas Nyambo from the University of Mpumalanga, South Africa. So it is an honor to be here again today. Today, actually, I will be presenting or reporting on the phytochemical composition of two nematicidal plant extracts. So these are the two nematicidal plant extracts that are actually found in South Africa. We have Tabana montana, and the other one is Mario angolensis. The one with the round or oval shape, it's the Tabana montana. So as we all know that they need to continue producing enough good quality of food, it's one of our everyday talk. It is important to look into the factors that can contribute towards improving food quality. And we all know that the agricultural industry is actually threatened by a lot of factors, starting from climate change into the quality of soil, as the presenter has talked about, and also go into the issue of pests and diseases. And one of the major pests, it's nematodes. Nematodes have been reported to cause too many damages in agricultural sector if they are not even controlled, such that even a 100% crop failure. However, a lot of work have been done by different authors through trying to find alternative control or control methods. Because when you look into the commercial industry or commercial agricultural industry, the use of this the way they control nematodes is through the use of nematicidal or synthetic chemicals. And due to the overgrowing concern about the harmful effect that these chemicals have on the environment as well as on people's health and also animal health, it has resulted to some of them being withdrawn from the market. And then these then facilitated or looked for alternative control methods that can be human healthy, environmental friendly, as well as animal friendly. And the use of plant extract have gained too much popularity in the last 2 decades or last decades due to its friendliness in the environment as well as on human health. Different reports have shown that as much as these plant extracts are actually doing well, they are managing nematodes in a very friendly way, but its adoption to the agricultural industry is actually very low. And different authors have reported that it's actually due to the inconsistencies that some of these plant extracts are having. When you look into one plant extract controlling the nematodes, and then in the other years actually failing to control, and it has been associated with a lot of factors, starting from seasonal factors, where the plant extract was collected, the storage, which looked into the stability of it. So actually this is one of the it's part of a big project that is ongoing, but today I will actually be presenting on the phytochemicals, what is really present in this plant extract. So we conducted 2 set of studies at the University of Mpumalanga. We collected these plant extracts from the wild because they are grown from the wild, and then they were identified and proved to actually be Mario angolensis and Tabana montana. So we did a greenhouse study, a greenhouse experiment where we planted these tomato plants, and then at 2 true leaf stage, then we inoculated nematodes, and then we applied our control treatments, which is the 2 plant extracts. And then the other one, it was a lab experiment where we tested the qualitative analysis of these plant phytochemicals, and then we also did the quantitative analysis. One can ask, why only those phytochemicals? Actually, it's from literature. Literature have proven that these phytochemicals have been actually associated with the nematodes management. So we had to check these phytochemicals. And then we collected or recorded the phytochemicals using a method of color changes and also the nematodes. Yeah. And also the nematodes variables from the soil and from the roots. So what is really happening? When you look into our results, you can see that these two plant extracts, as I said, that they have been reported to manage nematodes successfully by different authors. And when you look into these phytochemicals, it shows that all the tested phytochemicals were present in these two plant extract, except for TE, which is Tabana montana elegans, where we saw the absence of steroids and terpenoids. And I'm going to explain what does the importance of that. And then we did the quantitative, and then we are seeing Mario angolensis having more of these total flavonoids, total alkaloids, as well as total saponins compared to the other plant extract, which is Tabana montana elegans. And when you look into the greenhouse study, we are seeing also differences in response of these nematodes towards these two plant extracts. Mario angolensis continually outperforming Tabana montana in the suppression of nematodes. And this is evident enough because when those phytochemicals, Eli said that have been reported to be associated with the management of nematodes. So the presence of it actually determine the effectiveness of it in the management of nematodes. And different authors have reported these phytochemicals being responsible for the management of nematodes, just to acknowledge some few. And when you look at Chin 2018, he reported flavonoid being responsible for inducing the quiescence by slowing down the movement of nematodes and also modifying their migration by repelling and killing the nematodes. And Desmond 2020 reported also that these flavonoids they played a very important role in soybean resistance towards a malodicane incognita. On tannins have been reported to be involved in plant resistance to insect herbivory, and there is also a report on the correlation. When you look at the correlation between the tannin and tannin accumulation and nematodes resistance, which shows that actually the effect of tannins or the presence of tannins in the plants does contribute towards the nematodes resistance. And Raphael 2020 also reported saponins as one of the phytochemicals that we observed above on the table, responsible for actually its presence. The chemical composition of it can be used as natural nematicidal. And continuing looking at Ibrahim and Sor, he reported that the highest or the presence of saponins that were actually applied, or saponins that were applied as crude extract in the management of nematodes, showed 100% nematodes inhibition or egg inhibition. And the presence of higher saponins in the current study, it shows that this study actually can contribute towards the effectiveness of the nematodes, and as it has been proven in the past. However, this whole study does not actually address the inconsistencies of why is this plant extract keep on changing each and every year, where 1 year is controlling the nematodes, the other year is not controlling the nematodes. As I said, that we're actually working on it's a bigger project, when some actually looking into the application rate, application time, when are you supposed to apply this plant extract, and also the application rate, for how many times are you supposed to plant extract, because we are trying to bring this plant extract to the market, trying to commercialize it, because we know the importance that they are having, and yes, the importance is that they are having. So to continue reporting on other phytochemicals like the terpenoids have been reported to inhibit the reproduction of Melodicum javanica. And to understand what is really present in the phytochemicals or in the plant extract, for example, if you really want to inhibit reproduction, you know exactly that you can go and just extract the terpenoids instead of just using the whole plant extract. So understanding what is really present in the plant extract is one of the most, and up to date, these plant extract have been reported to control nematodes as crude extract. However, there is no studies that actually look into what is really present inside the plant extract, what contributes towards the management of these nematodes. So in conclusion, we are observing that the presence of these phytochemicals in the study shows that this plant extract is actually a source of secondary metabolites. And it is very important that we look into how or when or where are we supposed to keep this plant extract, because there is an ongoing talk that actually ongoing reports that actually look into after collecting this plant extract, how you store them or how long you keep them contributes towards the presence of the chemical composition. It is believed that the more you store them, the more these chemical compositions are breaking down, and then you end up losing them. So it's very important that when we try to put this plant extract into the market, to also try to promote them for the farmers, to the farmers, it's very important that we understand the issue of storage. We understand at what age are we supposed to collect them, because without understanding that, it will be forever. We'll keep on reporting, but then the uptake or adoption of it will actually forever low. So thank you.
Thank you, Mr. Nyambo, for your very nice speeches. Does anybody want to ask a question?
Excellent presentation. You should know that I have sent already a picture with you to your Miss President of your university directly, to know that she will know that you have been here and you presented a perfect paper. One question is, these two plants are, I think, woody plants. So it's quite difficult, as you mentioned, to extract these active substances and then to preserve them and to use them. Close the. So my question is, have you ever thought to use those plants as, because Mihai is here, also to use them in the field, to plant them in the field? Do their root system produce this type of active substances, or do you think that they can be used as shelters or windbreaks, or in order to have a side effect on the soil somehow?
I'm not sure if I got your question, but however, this plant extracts are actually found more in the wild, and some of them are even found on along the roads in some of the villages. So not only that these plant extracts have nematicidal properties, however, our grandfathers have been using this plant extract as a form of medicinal plants. So I'm not sure about cultivation, but I know that they're actually grown wildly in the wild. They're actually grown on their own. But it's we're actually talking because my PhD also focuses on the use of this plant extract, however, but in another form. So it's a good proposal. Maybe I can look into that, try to check if it's possible to cultivate them, because if we can cultivate and multiply them, then it can be of good use instead of relying on nature producing them. But we've never cultivated them.
Just to mention that we had a PhD, a very good PhD thesis, where we tried to to clean the soil by using certainly annual plants like marigold, tagetes, and some other. It was mentioned here by Sandra also about the white mustard or yellow mustard, Sinapis alba or Facelia. So there are some known plants that have nematocide effect, but they are annual plants, so they can be easily included in the crop rotation. But in the same time, it should be interesting to see if we could involve some wild bushes or wild trees in order to be planted somehow in our fields, production fields, and having some nematocide or protective effect. Thank you.
Thank you.
Now we will move on to the next presentation. It will be online, and the speaker is Amina Hamadi from Algeria. She will present research on characterization on soil fauna, macrofauna, and mesofauna under different agroforestry practices in the northwest foothills of Dakhra.
Yes, we can hear you. Please share the presentation.
Okay. Good evening, good afternoon. Everywhere you are. So,
We can't hear. It's okay. It's okay.
yeah.
Please put on the slideshows. Okay. Good luck. You can, Amina, you can close the video to have more space on the net. Your camera, sorry, your camera. You can close. Shut the video. Yeah. Okay.
see. And
Amina, can you hear us? Can you see us? Because we lost your presentation. I would suggest, if you can, to send the presentation, the PPT presentation, to Anna by WeTransfer or by any mean.
WhatsApp?
Yes, by WhatsApp. Yes. Send the presentation. We will try to download it here, and then we will try to present it from here. Okay.
Okay.
We will continue with the next presentation. Then, meanwhile, you can send your presentation here. We will upload it on our computer here, and we will try to present it from here. You will present it a little bit later. Okay? Send it by WhatsApp to Anna. Thank you. Bye.
Thank you.
Bye-bye.
Bye.
Thank you, Amina. The next presentation will be done by Muqdat Bingöl from Urdu University, and he will speak about research on important olive diseases found in Turkey.
Hello, gentlemen and lady. My presentation subject, olive disease infant Turkey. Here, Turkish maps. My university, my city for the olive tree. Historical development of olive. The olive tree, a species of the genus Olea in the family Olaceae, is a perennial Mediterranean plant. Transformation of the wild olive Olea, Europe, into cultivated plants, Stiva was first realized Anatolia, Eastern Mediterranean and Southern Asia Minor, 4000 BC, the olive. The homeland of olive is Turkey. From olives spread all over the world. Tried 3 main roads. First route Egypt to Tunisia and Morocco. Second route Anatolia, the Aegean, Iceland, Greece, Italy, Spain, and 3 together Iran to Pakistan and China. Today, cultivation is economically practiced on the total area 7,646,209. Olive production in the world. Olive production is carried out economically in 38 countries in the world due to its spatial climate recombinance of the olive plants. In the world, 16.6 million tons of olive oil product on approximately 10.6 million hectares of land. The interesting demand for olive products such as olive oil and table oils in the world in recent years, olive cultivation has started practiced economically not only Mediterranean coastal countries, but also in other countries such as Argentina and Chile and Peru. Olive production in Turkey, due to its geographical location and Mediterranean climate characteristics according to the list data. Turkey is the world's first largest producer of the table olives and second largest producer of olives. In Turkey, olive production areas are concentrated in the Aegean and Mediterranean regions. The most important provinces in olive area are Aydın, İzmir, Muğla, Balıkesir, and Çanakkale. Here, 2022 years production of olive in the Turkey. For the disease, pesticide, fungi, and weeds are the factors that cause the most important crop losses in olive. The dengue caused the bifactors in olive production are correlated approximately 30% and 50% of the disease caused by pesticide. Important pesticides for the olive tree, Bacteria olea gumlein, Teparitide, Pyrus olea bern, Cecita olea oliver, Coxide, Piscilit, Eropilla olivina costa, Paratolia olea col. Important olive disease in Turkey. 1. Verticillium dehilae. The disease has two genotypes, symptoms, acute wild and chronic wild. Acute wild occurs from later winter to early spring, shoot and the branches suddenly dry up. Chronic wild symptoms begin to pair to spring, usually disease symptoms on the flower appear before flower symptoms appear. Methods of struggle. Cultural methods. Similar cultural methods for the fungal disease. Healthy production material and spring should be used. Fertilization should be done according to leaf and soil analysis. Weeds should be controlled. Chemical control. There is no effective chemical control. This is picture symptoms in bundles and symptoms on a tree branch. Symptoms on leaves. To disease, Pseudomonas saxifoli. Bacteria in the crown green live growths and warts rise to surface of fresh growths and warts in humid and rainy water from it easy spread by rainwater, wind and insects. The warts are small and rounded or occur in wounds on annual shoots as the result of leaf, flower and fruit fall. Methods, cultural measures. Pulling tools should be discontinued frequently by dipping them 10% sodium hydrochloride. Chemical control. The garden should be checked in usually in August when the symptoms of warts and warts are omnivores and the bacteria are not active. And the dried branches with many warts should be cleaned and the ones should be dried with a 5% shouldn't of ice stone. Here, tumor symptoms. tumor symptoms on branches, tumor symptoms on branches. 3 disease, Propaganda oligea. The first symptoms are black sheet gray round shop on the upper surface of the leaves in spring. Because of the appearance, the disease in coloring spot disease. Cultural measures. Fertilization and irrigation should be done according to technique. Excess nitrogen fertilizer should be not used. Trees should be pruned in a way allow air, light, dry branches, and trees should be pruned and cleaned. Chemical control. First spraying just before fall shoots appear. Second spraying after the flower buds become prominent before flowers bloom. Here the picture, the size, symptom on olives leaf. Coletetricum glossoperides. The first symptoms on olive fruits appear as regular or irregular growing when the fruits ripen. The disease agents can infect the fruit before and after the ripening. In years when the disease is severely infected, there is the discard in the product, but to 50%. Olive anthracnose causes the fruit to lose its stable qualities and negatively activates the olive quietly in insecticide at acidity and peroxide oil of the olive oils abundant from these fruits. Cultural measures is the decide the leaves and fruits falling to ground should be collected and destroyed. Olive fly control should be carried out to the root surface of the disease. Avoid dense planting. Chemical control spraying time on spraying before the flowering. If May and June are rainy, another spraying in done when the fruits reach the size of chickpeas. Coletetricum glossoperides picture. Leaf anthracnose, anthracnose in fruit, anthracnose in fruit. Armillera malla. In infected trees should be formation is reduced, leaves turn yellow and fall off. Shoots and branches begin to dry out and eventually the tree die completely. The formation of the disease symptoms and date of the trees can occur within 4 years. Cultural measures. Trees should not be planted deep on the surface. Irrigation should be avoided. Root forming gas of the ground should be destroyed. Chemical control. If the disease has just started, after the diseased roots are cut and the diseased parts are sprayed, 5% Bordeaux mixture and 2% göz taşı should be applied to these places with brush. Here I'm Veramella, fungi on the roots, Rosalina nectaris. The economic loss in infant as Rosalina root. Disease causes trees to dry out. Fruit yield and quickly discards. Fruits fall off before they are large and ripe. When the bark of the diseased root removed, a weight of the mycelium is visible under the bark. Cultural measures. Gardens should not be explicit on moving and water rating soils. Soil plant on the roots, colors, springs, and the tree should be discovered. Chemical control, if disease has just started after the diseased roots are cut and the diseased part are 5% Bordeaux mixture and 2% Gösterşe. Should be applied to place with the brush after the dry is putty. Here Rossellina nectaris symptoms of the disease on the leaf and root. Olive viruses disease, olive latent sebomavirus, Arabis mosaic nepovirus, cherry leaf roll nepovirus, cucumber mosaic virus, strawberry Latin green spot nepovirus. This virus for the take nematode. Virus control and methods. Certified virus-free production materials should be used. New olive groves should be established in the areas free of vector nematodes. Olive groves should be cleaned of the weeds. Discussion and collection. Data on disease in olive oils were abated from 25 olive products in Didim, Söke, Germencik district in Aydın province, Milas, Bodrum, Fethiye district in Muğla province, Erdek and Edremit district in Balıkesir province as result of the 20 question survey. In olive growing areas, control is mostly based on oiled hobbits. When they are going to apply chemical control, the applied dose and the applied method on the use should be determined. They should information about dengue caused the chemical control to environment. Thank you for listening. Very sorry, I am some excited because first conference.
Thank you very much, Muqtat. Thank you for your presentation, and I also want to congratulate you because for your work here in our university, because Muqtat is our Erasmus student right now, and I can call him also our colleague. So thank you. If there are any questions for Muqtat?
No, okay. Thank you.
No questions? Okay, then let's move on to our next speaker, Rivonino Ubisi from University of Mpumalanga from South Africa. Will present application effect of Encephalartos velosus soil on growth and the yield of Swiss chard and mustard sustainable approach. The presentation will be online. Okay, so we'll move on to the next speaker, Alexandru Dumitru Ilie
from Pietroasa Research Station for viticulture and wine making from Romania. He will present evaluating the applicability of passive remote sensing technology with multirotor drone in precision viticulture.
Thank you.
Please.
Okay, so thank you for the invitation and the possibility to present my master degree thesis here in front of this beautiful audience. My thesis was around new technology. It doesn't happen to us for more than 10 or 20 years, this topic. So my team was to evaluate the vineyard and to see how can we do, what can we do, and how to analyze this from a different perspective that we used to do it in the past. Short introduction about remote sensing. It's a branch of geomatics that deals with the detection, measurement, and recording of electromagnetic radiation, reflected or transmitted. So it's important that the sensor that it measures is not in contact with the plant. We use two type of models to measure: photographic models and vegetation index. The photogrammetric model, it uses only the visible spectrum of the electromagnetic field, and the vegetation indices uses also the infrared spectrum. Another difference which is very important, we have in remote sensing, we have two types of this, the active sensing and the passive sensing remote. In the passive sensing, we use the sunlight to measure. In the active sensing, the sensor is sending the impulse to make the measurement. So this is quite important. In my study, I used the drone, but you can also make, like my colleague before, do it with the satellite. The small difference here is that the satellite has the pixel, the ground sampling distance, it's much bigger. So they work with like 5 meters distance of a pixel. In a drone, like I work with 3 centimeters. So it's much smaller. Another thing very important, this is the image of the typical spectral signature of the vegetation. So if the vegetation is healthy, this is the spectral signal that it has. If it's not healthy, it will change. So it's very important that the plant absorb the red for the photosynthesis and expel the infrared to not burn. Yes? So it's quite simple. Take the red and skip the infrared. So we can measure this NDVI index, which is very important, that gives us information about the vigor of the plant. What we do with this vigor map, we will find maybe in the future, because it's a lot of tests to do in this field. Material and method. The research was conducted through the 2020 agricultural season with several units. I choose 3 different vineyard spots in Romania. They are quite different from soil perspective and also climate. The equipment used was a DJI Phantom 4 Advance, for which I used his camera, a 20 megapixel camera, but I also buy a Centera Double 4K. This is the special sensor that measures the infrared field. As a software program, I use a trial program for Pix4D fields to generate the elevation maps in the wineries, in the parcels that I choose. On Agremo, with the Agremo, I use it for plant counting number report, so to find the missing vines that were in the plots analyzed. So these are the results for each winery. I had two parcels which I analyzed. You know, we have from the past we have like maps, elevation maps of the big regions, but when you want to track and to take decision and to see difference in the small plots, it's good to have this kind of elevation maps on the small scale, because here we have like the parcels like 2.5 hectares or 5-6 hectares maximum. So it's something to have a big region map, or this is more approachable. As you can see, from this we have the information like exposition, slope, which is in the vineyard, for a vineyard or wine growing is very, wine grape growing is very important, because the sun, how the sun goes on the field, it's very important, and the wine accumulates sugar. If the exposition is more south, it's good to grow white grapes or easy drinking red. Or if you have exposition on the west side, it suits very well to grow red grapes for long-lasting red wine. Another important thing here, if you make an elevation map this year, and after 4 or 5 years you take this measurement again, you can see some erosion problems that could appear in the field. So this is another important information that you could have. The second report is the plant count report. So here I had I introduced to the program the exact area of the plot, and also the distance between the vine and the distance between the rows. And he made the calculation, and he told me that for the Cabernet Sauvignon, I'm almost 20% missing vines, and for Sauvignon Blanc in the second winery, only 8%. So they are very good, important information when you want to buy the vines to replant, maybe, or to know how much the field that is missing is not working, you know, because for each parcel you want to be full covered, to not have missing rows. For the third part, I went in the field, and I measured with the roulette, with the tape measure. I took the leaf, the canopy measurements of height and wind. And after that, I calculate leaf wall area and leaf row volume. These are the formulas for here. So for three parcels, I made this calculation, And after that, I correlate them with the NDVI vigor map, just to demonstrate that the measurement that I can take with the drone, it suits well with the measurements in the field. So, this is the NDVI map. These are the NDVI maps. As you can see, they are quite different. And all of them correlate in less than 2 or 3% with the physics measurements that I did, which this could be a good indicator that NDVI, it's a good measurement method if you want to know the vigor of a parcel, of a plot. Like a short conclusion about the study, this could be a new source of information for monitoring evolution of a plantation, easy and rapid assessment, understanding the variability of the plot, more accurate implementing of measurements needed, higher quality resolution obtained better than satellite or helicopter, and much cheaper, because if you want to fly with the helicopter, it will cost you a lot. Opportunities, wineries that manage to understand and use remote sensing technology will gain significant competitive advantage. Once the applicability of using drones in data collection is understood, the implementation of phytosanitary and viticultural management practices will be facilitated. A new branch of research with great exploitable potential is here. Reduction of grape acquisition cost and improvement of wine quality. So, some weaknesses. Understanding and implementing the technology can be challenging without a good background of physics, because not everybody understands the electromagnetic spectrum and what happens, not what we can see. It's related to what happens, in fact. Low interest in research regarding the use of new remote sensing technology for East European countries, limited technological foundation of the personnel that could use this technology in the winery. Threats, the primary needs for wineries to address already known issues and streamline their workflow. Acquisition cost of remote hardware, software, or services that may seem expensive. The need for retraining winery personnel to use new technology. And as some ideas for further research, this could be planning pruning during dormant period based on data obtained from NDVI index map to determine the crop load for the following year. Efficient treatment optimization by administrating substance in accordance with the NDVI index. So for now we are sprayed the pesticides and the fungicides based on the hectare. In the future, we can do this by knowing the exact value of the canopy, how much canopy we have in one zone. That amount I need, not to put it on the big scale. Identification and demonstration of a crop estimation model using passive sensing, remote sensing technology. The drone that I use also has a second index, vegetation index, which I want to use in the future. It's NDRA, it's a vegetation index that is correlated with foliar nitrogen also with the photosynthesis, which is very important because if the photosynthesis doesn't work, I have some information that there are some problems there. Thank you. This is my presentation.
Thank you very much for your interesting presentation. There are any questions? So no questions again. Okay, so thank you very much. We will return now to Amina's presentation about characterization of soil fauna and under different agroforestry practices in the northwest foothills of Dara.
So, do you hear me?
Yes, you can start, please.
Hello. Okay, so hello again. The presentation is about characterization of soil fauna, so macro and mesofauna, under different agroforestry system in the northwest of Algeria. Town is Mostaganem. So we have, we say that we have a different problem in this area of the Dahra, and this problem pose soil conservation and biodiversity evaluation, as well as of sustainable development in this area. So, in the soil, or just the surface of the soil, we can show different fauna that are engineer fertility soils, and in this area we can the agricultural land has led to degradation of soil structure and use of biological practices, and therefore of the loss of the biological quality of this soil. Next. So we choose as a solution the agroforestry system. We have characterized different soil and fauna soil under this practices agroforestry, for sure that the agroforestry system is the excellent system of management of the soil between the other practices. Next. So the context of this the work is to show the agroforestry potential as assess its impacts on faunal diversity on agricultural land where the farmers use traditional techniques. Next. So we become to show the Algeria. So Algeria is located in the north of Africa, in the Basin Mediterranean Sea, and the town of Mostaganem is situated in the northwest of Algeria that we see, like we see in the pictures. The geographical situation of the study area, we can show that the study area or zone study, it was of 335 hectares of surfaces. Next. So this is the study area in 3D that should show that the area and the lands agriculture are situated in the foothills of the mountain of Dahra, Algeria. The overview of climate of this area are in the climate Mediterranean in the bioclimate pardon. So the study area is characterized by Mediterranean semi-arid bioclimatic flora with 2 seasons, a rain season in the winter and the dry season in the summer, belonging to the CSA class hot summer Mediterranean climate according to the Köppen. We can see in the weight or in the rain season the soil without plants, and the most problem are the erosion of the soils. And in the hot season also we have work and yes, the soil work, the practices soils, and the vegetation crop. Next. Also, this area was chosen because they have a lot of problems. Between this problem are next. The first problem are the courses luminous graced terrain. In French, we say les terrains graisseux, limoneux, donc elle glisse avec la pluie. The second problem, the 70% of agricultural land in the study area are fragile soils and sensitive. The third problem, the area is subject to a multitude of degradation aggravated by a human process. The practices, the soil practices of human, adequate and poorly conducted mechanization cultural practice inappropriate. The practices are inappropriate in this area. And also we have the incoherent agricultural policy, and in the last, the climate of this area. Next. So, as the work in the area, we have experimental approach that we have choose a lot plots agriculture. The samples was chosen in agricultural plots. The plots are chosen between agroforestry system and monoculture. The agroforestry system was the tree and the culture, and in the second system as a control was just monoculture. We have two control, and in the second system we choose six system. In each system we have taken 3 cadra with 1 meter square, and in each cadra we find spelling was performed from early April to mid-May in 2021. The surface soil analysis is the most important. So at each plot, 3 samples were taken from the topsoil between 0-30 centimeter according the start filed round spanning design along the slope. After this is for taken the soils samples. And for the former samples, we have choose the experimental approach of 3 techniques. The first technique was hand storing of earthworms. The second was TSBF, and the third second was the Berber trap. Next. And this is this 3 technical was for the mesofauna and for the macrofauna, and for the mesofauna the technique was the Berles technique. So for the results, we choose as soil fertility the elements matter organic, carbon organic, nitrogen, and the report biological report carbon and nitrogen. So the results show that the system number 6 of agroforestry was the soil of system number 6 of agroforestry was the higher system of fertility compared with control. That's what shows that in the agroforestry system preserve the fertility of soil comparated between the control. The second result was about Lombricidae, the worms. So the worms in the all the worms in all the plots was high in the system agroforestry 4, that the system agroforestry compared to the control present favorable condition for the development of earworms. This suggests the positive impact of the plant crop, tree plus crop. So the next results for macrofauna. Macrofauna was selected between different families. So we know that macrofauna are the most engineered fertility soils, and we take the families of for macrofauna. We take all the families, and for the results, we have an average density of macrofauna in the plots was higher in the system agroforestry tree compared about the control. These results confirm that the presence of the tree with the crop on the same land ensure the richness of macrofauna. Now we can show the taxonomy. Next. And frequency of macrofauna by order. So we can show that Hymenoptera are the most family presented in all the macrofauna of the soils in this area. Next, it can deduce